Hello and welcome, students of KS2003. This explainer is designed to help you really get a handle on the unit step, unit ramp, and unit impulse signals so you can walk into your first quiz feeling confident. So here's our game plan. We're going to start with some simple real-world analogies to build some intuition. Then we'll dive into the definitions for the unit step, the ramp, and the impulse one by one. And finally, we'll pull it all together so you know exactly what you need to remember for the quiz. All right, before we even touch the math, let's ground these abstract ideas. Honestly, the best way to understand these signals is to see them in the world all around us. First up, the unit step. I want you to just picture a light switch. Right now, it's off. That's a state of 0. Then, in an instant, you flip it. The light is on, and it stays on. That's a state of 1. That sudden jump from off to on, from 0 to 1, that is the whole idea behind the unit step signal. Okay, now for the next one. Imagine you're filling a big water tank. The water's flowing at a perfectly steady, constant rate. The water level doesn't just jump up, right? It rises smoothly, steadily, over time. The longer it's on, the higher it gets. That constant linear climb is the perfect picture of a unit ramp. And last but not least, the unit impulse. Think about a single, sharp knock on a door. It happens at one specific moment, and then it's over. It's super brief, but it has a definite, noticeable impact. This is a fantastic starting point for thinking about the impulse signal. Okay, let's dig into our first signal. We're going to see how that light switch idea gets turned into the formal mathematical definition you'll see in your course. And here it is. So mathematically, the unit step, u of t, is pretty simple. For all negative time, anything before time 0, its value is just 0. Then, right at the moment t equals 0, it instantly jumps up to 1, and it just stays at 1 forever. It's the perfect way to model anything that just switches on. Now, this is really important. Understanding what happens when we shift the signal. So look at u of t minus 2. The turn-on event happens whenever the stuff inside the parentheses equals 0. So t minus 2 equals 0, which means t must equal 2. It's the same light switch, you're just flipping it 2 seconds later. Okay, quick pop quiz. Based on what we just saw, what's the value of the standard unit step signal at time t equals -1? It's 0. Exactly. Because at t equals -1, we're still in that t is less than 0 zone. The switch hasn't been flipped yet. Awesome. Now let's take that simple on-off switch idea and use it to build our next signal, the one that grows nice and steady, just like the water in that tank. So this is the unit ramp, r of t. It's defined as t times u of t. Now that u of t part basically acts like a gate. When time is negative, u of t is 0, so it shuts the whole thing off. The ramp is 0. But once time is positive, u of t becomes 1, so r of t is just equal to t. That gives us a perfect straight line climbing up from the origin with a slope of 1. And check this out, there's a really deep connection here. The ramp is actually the integral of the step. You can think of it like this. For every single moment that the unit step is on, it's adding a tiny bit to the total accumulated area, which is what makes the ramp's height grow and grow. So, with that definition in mind, let's try a quick one. If our unit ramp signal has been running for 3 seconds, what would its value be at t equals 3? It's just 3. You got it. Since we're at a positive time, the rule is simple. R of t equals t. So the answer is just 3. All right, it's time. Let's tackle the signal that sometimes feels a little tricky, the unit impulse, or delta of t. But I promise, once you understand what it's for, you'll see it's one of the most powerful ideas in all of engineering. And here is my #1 piece of advice for you. Please, do not get hung up trying to draw or visualize the impulse. The key is not what it looks like, the key is what it does. Its entire identity is based on its job. Okay, so the impulse is defined by 2 very strange-sounding properties. First, it's 0 everywhere except for a single infinitesimally small moment at t equals 0. And second, even though it's infinitely thin, its total area, or you could say its strength, is exactly 1. Yeah, it's a weird concept, but these 2 rules are what give it its magic. And that magic leads us to this, its superpower. This is called the sifting property, and I'm not exaggerating when I say this is one of the most important ideas you're going to learn in this entire course. So what on earth does that equation mean? Well, in plain English, it means that when you multiply some other signal, x of t, by a shifted impulse and then integrate, the impulse acts like a perfect filter. It sifts through every single value of your signal and picks out just one, the value at the exact moment where the impulse is. Let's put that superpower to work right now. Here's an example straight from your notes. How would you solve the integral of t squared plus 1 multiplied by delta of t minus 2? And this is just a perfect illustration of the property. The impulse, delta of t minus 2, lives at t equals 2. So its only job is to go over to our function, that t squared plus 1, and find out its value at t equals 2. So we just plug it in. 2 squared is 4, plus 1 is 5. The impulse sifted out the value 5, and that's the answer to the whole integral. Pretty neat, right? Okay, let's bring it all home. We're going to connect these 3 signals and make sure you know the absolute key points you need to have locked down before quiz 1. You see, these 3 signals aren't random. They're actually a family, and they're connected by calculus. If you start with the impulse and you integrate it, you get the step. Then, if you integrate the step, you get the ramp. It's this beautiful, logical progression. So, if you remember nothing else, remember these 3 things for your quiz. Number 1, a shifted step, u of t minus t0, turns on at t equals t0. Number 2, the ramp is the integral of the step. And number 3, the superpower of a shifted impulse is to sift out a signal's value at that exact spot, t0. If you can master these 3 fundamental building blocks, you are going to be in fantastic shape for your quiz and for the rest of the course. Good luck with your studies.